Alright, so how do we know whether two strings are anagrams? An anagram is when you can rearrange the letter in one word to make the other word. But another requirement is that they have to be the same length. So let's say we add another C here. We know immediately that CBAC is not an anagram of ABC because CBAC has 4 letters and ABC has 1 letter. But let's say they do have the same number of letters. One way you could see if they're anagrams is by finding every permutation of the first word and comparing it to the second word. So does ABC equal CBA? No. Does ACB equal CBA? No. Does CAB equal CBA? No. And you can keep doing that and checking whether the permutation equals the second word. But that's extremely inefficient. What you could do is think about how you're actually determining whether the first word is an anagram of the second word. You're not actually going through ABC and finding every permutation and comparing it to the second word. What you're really doing is going through each letter in the first word and comparing it to the second word, see if it has that letter and the number. So how we can do that is we can add the letters and counts of the first word into a data structure and then compare those same letters and counts to the letters and counts in the second word. So let's see how that's done. Let's start with the letter A in the first word. Does the data structure have the letter A? No. So we add it there. Letter A with a count of 1. Now we're at the letter B. Does the data structure have the letter B? No. So we add it with a count of 1. Does the data structure have the letter C? No. So we add that also with the count of 1. So now we're at the end of the first word. What we can do is think about this data structure as the number of letters that are available. So we have 1 A available, 1 B available, and 1 C available. So now we look at the second word. Look at the first letter. It's C. Now you compare that to the count of the letter C in the data structure. Does the data structure have any C's available? Yes, it does. So what we're going to do, sorry about that, is we're going to decrement that count in the data structure by 1. Now we move over to the next letter in the data structure, and that's the letter B. Does the data structure have any B's available? Yes, it does. So we decrement that. We get 0. Finally, we move over to the last letter, the letter A. Does the data structure have any letters A available? Yes, it does. It has 1. Decrement that, and we're done. We can tell that ABC is a permutation of CBA because we've gone through every letter in the last word and compared it to the data structure, and we see they're all zeros. Now let me show you an example of 2 words that are not anagrams. Instead of CBA, I can change this to CA. So now let's do what we did originally. Go over each letter in the first word and add it to a data structure along with its count. A is kind of 1. Next we go to B with a 1 and C with a 1. Now we go over to the second word. First letter, the letter C. Does the data structure have any C's available? Yes, it does. So we decrement that. Now we go over to the second C. Does the data structure have any C's available? No, it does not. It has 0 C's available. When we decrement that, we're now at -1. And what that shows you is there are more C's in the second word than in the first word. So we'd return false. Now I can show you all of this in code. All right, so as we talked about before, if the 2 words don't have the same length, they're definitely not anagrams. So we can go ahead and write that out. So if s.length doesn't equal t.length, we can immediately return false. Next step is to keep track of all of the letters and the count of those letters of the first word. We can do that by adding that to an object, and we'll call that one letter count. So let letter count equal an object. The next step is to actually add those to the object. So we're going to loop over each of the letters, and if they're not in the data structure already, the letter count object, we're going to initialize the value to 1, as in it's the first time we're seeing it. And if not, if we have seen this letter before, then we'll just increment the count of that letter. That'll look something like this. For every letter of the first word, if letter count, letter, if it equals undefined, meaning we've never seen it before, then we're going to add it. Else, so if we have seen it before, we'll just increment the count. Letter count, letter, plus plus. Okay. Now we need to loop over every letter in the second word and compare those counts to the first word. So for let letter of T, T being the second word, first thing we're going to do is we'll check if that letter exists in the letter count object. Remember, the letter count object has all the letters in their counts of the first word. So if this letter is not in the first word, we can just return false. Because if there's a letter in the second word that doesn't exist in the first word, then they're not anagrams. Next, we can check if the count of this letter exceeds the count of this letter in the first word. So if letter count letter is less than 1, you can also return false. All right, so if we've gotten past these first two if statements, it means that the current count of the letter we're on in the second word doesn't exceed the total count of this letter in the first word. So all we have to do is decrement that letter. So letter count, letter minus minus. And if we've gotten all the way through all these steps, it means it is definitely an anagram, so return true. And if you want to see a written version of this code or a written explanation of it, just check out the link in the description below. See you next time.